At first, we start up our system by consuming one of the dataset. Our system is extremely fast. It is able to consume 1 million events per second. Next, we are going to connect our web-based user interface with our Morse system. As you can see, these are the top 12 primary alarms that shows up at that particular time. If we click on one of the primary alarms, we can see all the secondary alarms that have been clustered with it. Next, we're going to refresh the list of primary alarms. And now you can see a primary alarm that corresponds to one of the attack in the dataset. It is highlighted in red due to the high accumulated weight of the secondary alarm. Next, we're going to perform different types of search from this primary alarm. At first, we are going to perform a naive DFS. The resulted graph is extremely large and would take a really long time to render. That is why we truncated the graph for the sake of the time for this demo. As you can see, the truncated graph is very hard to understand. Now you're going to perform Sleuth's cost-based search. This also results in a very large graph, which we also truncate. Although the graph is somewhat readable, it is still too large and very hard to understand what is going on with the attack campaign. Now we're going to perform our Morse's forward search. It results in a very compact graph depicting the attack scenario clearly. From the attack graph, you can see that a compromised Firefox plugin drops a payload called GTCache in the system that gets executed. The GTCache process later gets its privilege escalated and downloads another file, ztemp, from the network. This process performs some recon and also exfiltrates the information through the network.